3. Section 3. So most of the topic from the section 3 or the concept we are going to apply here, like the concept of time value of money, discounting factor. We have the topic of cost of capital from section 3. Even the risk and return from the section 3, we're going to apply here. So you find that in advanced level, you will not be given specifically that this is the cost of capital, or this is the risk and return, or this is the time value of money. So you find that it is incorporated in other topic. It is incorporated in other topic. So you look at the topic 1, and now class it will be a marathon because of time, so that we can at least get the time for revision. That's right. Advanced capital budgeting. Advanced capital budgeting. Advanced capital budgeting. Look at you. So we have, this is not the new concept. We have seen it under section 3. That is Mombona NBV. NBV. So this level, we call it advanced capital budgeting. So when we say capital budgeting, that if the company have a big project, if the company have the big project which they want to invest, they will not invest without doing the budget. They will not invest without doing the budget. So they must do the budget to check whether we have enough capital to install this machine. And if we install this machine, what could be the effect? What could be the effect? So that as a finance manager, because you will be a finance manager, you will be required to advise the board on when to take this project and when to abandon this project. So we can now have a subtopic, incorporation of risk. 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 Then to put that slash and say uncertainty or under uncertainty. Under uncertainty. Incorporation of risk under uncertainty. So when we say uncertainty, what do we mean? It's something that we don't know. So we can have explanation and say under the risk environment. Under the risk environment, under the risk environment, comma, under the risk environment, comma, the state of nature in bracket events, the state of nature in bracket events, the state of nature in bracket events that will prevail are not known in advance. That will prevail are not known in advance, comma, however, their probabilities are given. However, their probabilities are given. However, the probabilities are given. So that is and then we have another point. That is the under risk environment. So we say, when you say under risk environment, that is the under risk of certainty, because you know what will happen under the risk of certainty. So that first point is explaining the risk under certainty. Then we have the second point, which now explaining the risk under uncertainty. You say under uncertainty environment, the state of nature which will prevail, the state of nature which will prevail are not known in advance, and their probabilities are not given, So that is just a small explanation. So our main concern is to look at how do we handle this risk? Even though tulikuwa tumeshafanya section 3, but we have to remind ourselves, how do we handle this risk? So you write tools used to handle risk. Tools used to handle risk. Tool used to handle risk. The first tool is the expected monetary value. The expected monetary value in bracket E and V. Expected monetary value. Then number 2, standard deviation. Standard deviation. And then we have number 3, coefficient of variation. In bracket CV. Coefficient of variation in bracket CV. So when we talk of expected monetary value, this is just NPV. The net present value. But this net present value, you must have expected. And something which you are expecting, it associated with the probability, because it is not something that you know exactly this is what is going to happen, but you expect. So you associate it with the probabilities. So once you get the NPV, multiply with the probabilities, then that one will be now either expected monetary value or expected NBV. And then we have standard deviation. So if we remind ourselves, standard deviation we used to measure absolute risk. And we said something absolute is something which is 100%. And coefficient of variation, this one is used to measure relative risk. Relative risk. It's used to measure the relative risk. So we can have a small illustration. So write illustration. So we have to be faster. Illustration. We have the state of nature. A, B, C, and then we have probabilities. 0, the 3, 2, will be 1, 5, and then we have the cash flows. We have the cash flow returns. So let's have two projects. Just a minute. So let's have two projects, that is the project X and project Y. So this project, we have a returns here 10, 15, and then this one you can have 20, and then here you have 20, 25, and then we have 30. Remember, these are the returns. So whenever you get the returns, You make sure that these returns are in percentage. These returns are in percentage. We learned this concept in portfolio analysis. All the returns should be in terms of percentage. Then we have been told required expected, number one, expected monetary value. Number two, standard deviation. And then number three is the CV. So given this illustration, we need now to see how much is our expected monetary value and how much is standard deviation, CV. So can our solution. So how do we get expected monetary value? You get the expected monetary value. You get expected monetary value by taking the return, times the probabilities. The return times the probabilities. So we'll have to get the return for project X, the return for project Y. So I will have project X, which these are associated probabilities, and these are the returns. So we take 0.3 times 10 plus 0.2 times 15 plus 0.5 times 20. And then for Y, return Y, probabilities will be the same. 0.3 times the return 20 plus 0.2 times 25 plus 0.5 times 30. That one will give us the expected monetary value. So put your calculator. Uone zinakupea ngapi?
The first 6.
The first ni ngapi?
16.
16. Second one is?
17.
So these are now expected return. And then the second this side is a torsion. So the second requirement, they want the standard deviation. How do we get standard deviation? Najua maybe ulifanya QA kitambo.
Standard deviation is equal to return minus expected return. Summation of return minus expected return, then we square, then we multiply by the probability, then we get the square root.
Yes, we get the square root. So simply standard deviation is the root of what? The root of variance, right?
Oh yeah, the root of variance.
So now let's calculate this variance first. So let's calculate the variance. Which the variance is the get the return minus expected return squared, and then you multiply by probabilities. Which in our case, the return here is 10 minus, for the project X, 10 minus 16 squared times the probability, which is 0.3. Then to the other one will be 15 minus 16 squared times 0.2. 20 minus 16 squared times 0.5.
Oh, Malimu, the second return is 26, not 17. Return 26. Y. Yeah.
26. So how much is this?
The first one is 10.3. I finished them.
Yes, finish them and then sum it.
$19.
19. So that is the variance. So get the root of that variance. Get the root of that variance.
4.3589.
So put in two decimal place 4.3.
36.
36. Yes. So that is the standard deviation of the first one. That is the standard deviation of the first one. So you can get the standard deviation also for the second one. You take this minus the return, this minus the return, this minus the return square, multiply with the same probabilities. Uone hiyo itatupia ngapi?
They're the same, 19. Variance.
Variance is the
19.
same.
Yes.
Yes, it was 19 because it was ranging by 555, right?
Yeah.
So we have now, which is the same, that we can't have the coefficient of variation to the CV, the coefficient of variation, the CV. So how do we get CV? How do we get CV? How do we get CV? So CV, you take you take the standard deviation, you divide by expected return times 100%. You divide by expected return times 100%. So in our case, as CV for X, we have standard deviation 4.36. We divide by expected return, which is 16 times 100. So what will be our CV? What will be our CV? What will be our CV?
27.25.
27.25. So based on the two methods, you can see the level of risk in this project is very high, because if anything which is more than 1 or 0 in this risk, it is what? It is a volatile, or there is high risk. You can see the probabilities, the standard deviation is more than 1. The CV is also more than 1. So the level, if examiner asks you to advise the management, that you advise them on in terms of the level of risk. terms of level of risk. So that is just a reminder of how to calculate the standard deviation, the coefficient of variation, But now when it comes to this section, we have to introduce the new concept, which was not there in the other levels. Ulifanya kwa way, but it was a different approach. So we have now to introduce another concept here. This concept is advanced techniques of handling risk. Advanced technique of handling risk under uncertainty. Advanced techniques of handling risk under uncertainty. Advanced techniques of handling risk under uncertainty. So we have the first technique is simulation. The first technique is simulation. So if we define what is a simulation, it is simply what? Simulation is to what? To imitate the reality. To imitate the reality, or to copy the reality, or to copy the reality, So in this case, the examiner will give us, the examiner will need us to know the range, because they will give us the random number. So we will use that range to distribute that random numbers. From that random numbers, we use to get our cash flows. Once we get our cash flow, we discount. So we'll have now to know how to get the random range of a given scenario, So assuming we have an exercise here, which is running from 10, 20, 30, then we have the probabilities. Which run 2, 0, 3, and then 0, 5. So those required generate the random numbers, generate the random numbers, of the above variables. Generate the random numbers of the above variable. Shalika?
Yes, Chandika.
Okay, so the first thing when generating the random numbers, is to consider the place of decimal of probabilities. Consider the number of decimal of probabilities. So if you look at the number of decimal, we have this one is 1, 1, 1. So for one decimal place, you give what? 1 digit. You give one digit. For two decimal place, you give 2 digits. So utapata another one, tutapewa 0.0, 0.30, but this one is just 0.2. So it is one decimal. So the random number should be in the form of a 1 digit. So if it is 1 digit, then it means from 0 to 9. So let's generate now the random number for this project. So you have to get the cumulative probabilities. So first get cumulative probabilities, which I will accumulate this. So the first one, it will remain the same, 0.2, and then 0.2 plus 0.3, 0.5. 0.5 plus 0.5 will give 1. So these are accumulative probabilities. So from this cumulative, then we get the random range numbers. The random range numbers. So it will start now from 0 and then 2. So you assume this one is a whole number. 2, 3, and then 1. So tutachukua 0 less 1, tutakuja 0 to 1. 0 to 1. So una less 1 e. And then we start from this on the second range, which will be 2 to e you less 1, which is 4. And then from 4, we end up, this one is like 10. So 10 minus 1, which is 9. So that is the random range. So this is how to generate the random range. So that one, if you have been given one decimal place. What about if we have two decimal place? So what about if we have two decimal place? So if you have two decimal place, and that these are probabilities 0.20 and then 0.8, 0.8, 0.8. So if we have these two these probabilities, you find that this is two decimal place. So two decimal place, you get 2 digits. So it will be now from 00 to 99. So it will be 00 to 99 because this one lazima ikue 2 digits. Ama 0 is not a digit.
It is a digit.
It is a digit. No? So
yeah,
you have to get the cumulative probabilities here, which this one will be 0.2, then this one will be 1. So our range will be 00 to subtract 1, 19. Then from there, go to 20, then to 100 minus 1, tutakuja 99. So that will be our range. So in this simulation of handling risk, so the first concept is to know how to generate the range. So once you know how to generate the range, you use this range to get the cash flow. You see, these are the cash flow. So we are not going to do a discounting direct using this cash flow. No, we'll be using the random numbers to allocate this cash flow. Using the random numbers to allocate this cash flow. So assuming now we have these are our cash flow, right? And then so maybe this is just 1 year project. This is 1 year project, and we have our random numbers. That is 5, 15, and also 8. So these are our random numbers. Because this CPA, it is good to know the concept. So if you understand the concept from the simple illustration like this, so if you could exam anatumia tu a lot of information, a lot of literature, but the concept may remain the same. So assuming that now this examiner has given you these random numbers, 15, 5, 15, 8, right? And then they ask you to do to get the expected net present value. Then ask you to get expected net present value. Maybe I've given you these random numbers. I can compare the cost of capital KE 10%. And then akakupea the IO, the initial outlay, ngapi? Like 5, right? And then anakuuliza expected net present net present value, expected net present value. So the first, you have done the first step. So the second step is to allocate the cash flow, So you will come here and write number of runs. So based on our random numbers, tunaweza guess tutapata how many runs? It is just one runs, right? Ukiangalia our cash flows ni 3 na tumepewa random numbers ni ngapi? Ni 3. Ni 3. Tungekuwa tumepewa random numbers hapa ikuwe 6, then tungejua tungetafuta two runs. So but now in this case we only have one run. So in this one run, and then we have random numbers. Have the random numbers. So these random numbers, we have 5, and then 18, 15, and then we have 8. These are random numbers. Random numbers. So from that random numbers, we use to get the cash flow. So you will come here to your range. So this is the first random number in the first run. So unakuja your random range hapa. 5 ina fall under which range? Yes?
Sorry, I ran out of data.
Oh, so umepotea kwanza wapi?
From when you were explaining the K is 10%.
Yeah, so I was saying, assuming that examiner asked us to get expected net present value, and then they have given us the random numbers, which is this one, 5, 15, 8. Also, they have given us the cost of capital, that is 10%. And they also given us the initial outlay of 5. That they ask you to get the expected net present value. So the first step is to get the runs. The first step is to know the number of runs. So how will you know the number of runs? You will know the number of runs based on the random numbers they have given you. So ukiangalia the random numbers, ingapi 1, 2, 3, na tuko na 3 cash flow. So it means it is just one run. Tungepewa digits hapa ifike 18. 18 tungejua tunaenda up to 6 runs. So unaangalia random numbers ndio inakusaidia kudetermine the runs. So ukishapata hiyo, then you allocate the run. So itakuwa first 5, 15 and 8. 5, 15 and 8. 5, 15 and 8. 5, 15 and 8. So for 5, 15 and 8, you come now, ushapata first ranks with 5. So what will be the cash flow? So you will come here to your range. 5 in a fall under which bracket? So 5 falls under this bracket. So you follow. If you fall under which that bracket, what is the cash flow? The cash flow is 30. So you bring it here, you will have your cash flow here. 30. The second one, 15. 15, I think tungeandika 15 because of the range number. So here tungeweka 3. Because of the range number, we will not get up to 15. So 3 in a fall under which bracket? In a fall under the second bracket, which the cash flow will be 20. The cash flow will be 20. And then 8 fall under the last bracket, which the cash flow will be 30. The cash flow will be 30. The cash flow will be 30. So now you have this one. Now you can rearrange. You can rearrange and get your cash flows 30, 20, and then 30. So for that, now you bring in your PFIFA or PFIF here. Bring in PFIF. So we say assume this is just 1 year. So if it is just 1 year, we will have 10% 1 year. We have 10% for 1 year. So 10%, how do we get the PFIF? Or when do we use the PFIF? You say to use the PFIF, that's why now we are bringing in the concept of time value of money. The concept of time value of money. We use PFIF when discounting a lump sum amount. When discounting a lump sum amount. And we say lump sum amount is something that it is paid once, either at the beginning or at the end of the project. That's why it is not regular. These are irregular cash flows. These are irregular cash flows. So the formula of getting now P50 is 1 plus R raised to -1, negative n. So get the discounting factor multiplied by the cash flows. So it will be 1.1, 0.8. So once you get it, multiply direct with the cash flow to give you the present value.
0.9091.
Multiply direct with the cash flow now, 30 for the first one.
27.273.
Put 2 decimal place, 27.23.
27.
Yes,
27.
27. The second one, the same discounting factor.
18.18.
18 into
1.18.
1.8. The last one.
27.27.
7.27. Now you have gotten now the present values, right? But examiner was asking expected net present value.
Net present value.
So get now expected net present value. Expected net present value. So expected net present value. The formula of getting expected net present value is to get expected or the present value, expected present value minus the initial outlay. Expected present value minus the initial outlay. So we can get this one. So the first one is 7.27 times the probabilities, which is 0.2 times 0.2 plus the second one, 18.18 times the probabilities, 0.3 plus 27.22 times 0.5 times 0.5. That one will give you expected present value. Then from there, you subtract the initial outlay, 5. Subtract the initial outlay, 5, to give you expected net present value. So